My name is Moshe Ben Simon. I am VP Product Management here in Fortinet. 20 years in the security space. I was a CISO, built some companies. My last startup was a deception company, basically that invented the market of deception back in 2014. I was the founder and CEO of TrapX. Sold my company to a different company and joined Fortinet almost 2.5 years ago, running here the FortiDeceptor and several other products lately that I got from my manager, Carl, that was pitched before me. So let's speak about deception and the FortiDeceptor product, how to use deception to protect OT and IT networks. So, one of the things that you discuss with security people and ask about deception, one of I call it the pop-up balloon that basically pop up when you ask, hey, what is deception? So the first reaction you get from people, it's basically, oh, I know deception is a honeypot. And honeypot, we know from the past, working, not working, always open source project, and etc. So this is the perception that people have in the past. And even today, you can find people that, yes, it's honeypot. So deception, it's rely on the honeypot idea. And just as an FYI, honeypots celebrate around 34 years when it just, pop up in the federal space in the US, was the first honeypot that somebody developed. And deception rely on the idea of honeypot, the idea of deceiving attacker to engage with a fake asset. But deception is a platform. It's a platform that allows you to deceive the attacker on each corner of the network. So if you look on a IT network, OT network, both of them, if you try to look on the silo of the network, you have basically 4 different angles. One is the infrastructure. Second is the endpoint and server. Third, it's the application. And fourth, this is the data. This is basically 4 areas in the network that once attacker compromise your network, he either will engage with all of them, part of them, or just single area in the network. The idea behind deception, it's like to have a mirror maze across your network, meaning no matter where the attacker will land, no matter where the attacker will look, right, left, forward, back, we will try to deceive him to engage with a fake asset and not with the real asset. The deceive will lead to detect. The detect will lead to forensics. Forensics will lead to threat intelligence. And threat intelligence will lead to mitigation. This is basically the concept of a deception platform. So now let's look on deception. In general, there is 2 kinds of deception in the market. There is the full stack deception. Mainly, it's a deception platform that provides more than a single layer of deception. And there is the half stack that rely on a single deception layer. In our case, we choose the full stack deception platform, where we have 4 different layers of deception capabilities that we implement on top of the real network. And basically, we create a shadow network that consists endpoint, server, IoT asset, OT asset, fake application, fake services, fake data. No matter where the attacker will go, it's a mirror maze. You just need one time to hit his head in the mirror and we will detect it. So let's see what is the 4 elements of the deception platform. First, it's the decoy. And yes, the decoy, it's the honeypot. However, on the deception platform, decoy become more sophisticated. They become more on scale. And I always call it's honeypot on steroid. It's not a next-gen honeypot because honeypot is a honeypot. It's basically on steroid because we use the virtualization technology to scale the decoy much more faster, much more enriched for engagement perspective, and much more on scale, meaning deploy it on-prem, data center, DMZ, cloud, remote location, IoT facilities like medical, healthcare, OT facilities, energy, manufacturers, utilities, electricity, you name it. So the decoy, it's basically one of the first component and one of the core component of any deception platform. You can find decoys that running the classical Windows Linux, but you can find IoT stuff, printers, network switches, fake web application, fake database, infrastructure like ES6, Elasticsearch, and etc. Also application like ERP, SAP, point of sale, medical devices, infusion pump. We have infusion pump decoys. And you name it, it's a long inventory of decoy. And also we allow you what we call bring your own decoy, meaning you can upload your gold image. We will take care and convert it into a decoy for you. So this is basically the first and the core layer. You have the real network and you have the shadow network. The shadow network running from the software. Nothing get out. We're just using IP addresses. The second layer, it's the lure, what we call the decoy services. If you have 5 FTP services, real one, guess what? With deception, you will have 50, if not 100 FTP services. You have 20 web application, guess what? You will have 150 web application. So any kind of service that you have, either expose it internally or externally to your contractor, remote connectivity, and etc. We will duplicate it. We will expand the attack surface. End of the day, it's a mathematical game. If you have 10 services and I will put 100 fake, I increase the chance that attacker will engage. The third module, it's what we call the network deception traffic. When you come to deal with a sophisticated attacker, these guys are not making noise once they compromise the internal network. They will passively sniff the network or actively reroute the network in order to collect information, running man-in-the-middle attack, ARP spoofing, responder, and etc. In order to catch their interest, we will send signals. I'm calling it a radio station of deception. We will send the right packet on the right time with the right information. So either attacker passively or actively sniff the network, he will get the real packets and he will get the fake packets. The fake packets will always be more interesting and attractive for him to follow the stream. The last one, it's basically what brings the deception the prime time. Because remember, when you deploy just decoy, it's always the question, what is the chance the attacker will touch the decoy? It's a good question, because if you have 1,000 endpoint and server and you deploy 500 decoy, it's 50% detection rate. Nobody here on this call will buy a security solution with 50% catch rate. The deception token, it's basically a package with fake keys, fake tokens that we deploy on the real endpoint and server, not on the fake, on the real one. It's an agentless technology that basically insert data, can be credentials, can be shortcuts, can be files, can be application, any kind of data that we know the attacker looking to collect from the compromised asset. It's basically reside there waiting for the attacker to extract it. If the attacker will run password dump tool like Mimikatz, he will dump the machine, he will get fake credentials. He will follow the fake credentials, he will get detected. So the deception token, it's basically what we do. We take the entire operating system, Linux, Mac, and Windows. We analyze where the attacker going after in the operating system level to find information. When we finish to map the entire OS, we insert fake instruction for the attacker. They are always look the real one, they are always look attractive, but they are always will deceive the attacker to engage with the decoy and not engage with the real asset. Now, if we go back to the mathematical example, 500 with 1,000 real devices, once you take the real devices, the endpoint and server, and put the deception token, you basically and logically convert your real endpoint and server into an honeypot. So your real endpoint and server become honeypot with the infrastructure honeypot, what we call decoys. You get over the real inventory. You have 1,500 fake points on the network compared to 1,000 real asset on your network. So you change the game in terms of what will be the chance the attacker will engage with the decoy. So the deception token solves the problem that basically block the deception over the honeypot industry to be in the prime time. So this is in general what is the expectation from a deception platform. Now let's take a look how we have the deception. So I took here like, generic network with several network VLANs that hosting data center, servers, application, Windows endpoint, IoTs, and OT infrastructure. FortiDeceptor, it's basically an appliance, virtual hardware. If it's a virtual, we support the whole virtualization from public cloud to private cloud, Hyper-V, ES6, KVM, GCP, AWS, and Azure. You name it, we support it. We plug the appliance into the network and basically introduce the appliance to the network. The appliance will connect, and for running the decoy, the appliance will learn the inventory of your network, what kind of OS services and etc. And we start taking IP addresses that nobody use. On each segment, he will take IP addresses that nobody use. Again, it's depending on your decision, or you can give the system algorithm to decide for you based on the inventory. So once we connect the FortiDeceptor to the infrastructure, we deploy the decoys and we deploy the tokens, because once we generate the decoys, deploy the decoys, we have a shadow network. The FortiDeceptor will generate the keys based on the decoy. Remember, each key must have destination. So if I generate the key without destination, it will not work. So first, the system will deploy decoy. The second, they will generate the keys, what we call the deception token. Now we have decoys that infrastructure level. The decoy know how to send traffic to the wire. It's a very limited traffic. We are not bombing the network. It's single packet that we send to the wire, and packet the attacker willing to get, not packet that he will surprise he get, because we can basically expose that we are exist. And the moment the attacker engage with the decoy, and there is two options for the attacker to engage with the decoy. First option, what we call direct engagement. The attacker run sniffing, reconnaissance, using a single exploit to compromise your network, like any kind of ransomware that spread. This is the direct engagement. The second engagement, it's based on the deception token. The attacker gets exposed to a fake information or fake token. He will execute, meaning follow the information inside the token. He will engage with the decoy. So basically, there is two options, either direct or using a token. Both of them, end of the day, will lead the attacker to engage with the decoy. Now, when he engages with the decoy, we will analyze the whole engagement. We can capture all the data from network traffic, binary traffic, command that he run against the decoy, data that he copy, data that he steal, that connection to the internet, connection to the internal network. The whole activities, like a security camera, fully record. We record, and during the engagement, we analyze the activities. We generate threat intelligence that we share with the infrastructure, SIEM, SOAR, threat hunting, and we also have connectors to your infrastructure, firewall, NAC, EDR, and we use them to isolate it or quarantine the attacker automatically without any user intervention. So this is in high level what we expect from a deception solution. So now let's take a pause on the technology and let's try to understand the value of deception, because if you look on the security industry today, there is many problems, but if you sitting with a CISO and try to narrow down the problem, the first problem, it's basically how long it takes you to detect an attacker. There is many research survey out there. Every year it's a different number. We start with 200 days, go down to 20, but the reality is different. The reality, when you open the news, you get some news on a breach, company running investigation. 3 weeks after, you get the announcement that, yes, we get a breach, and the attacker stay for a long time. So detection attacker is a challenging, and mainly the time to detect. Because time to detect is basically the damage. They will spend 1 day, the damage will be $1,000. They will spend 100 days, it will be millions of dollars. So the time to detect is very important. And if you look on the deception technology, we detect the attacker early in the kill chain. The moment the attacker lands in the network, looking right, left, forward, and back, we try to deceive him, meaning that we try to engage early in the kill chain to detect the attacker. And most of the detection from a deception tool, it's always early in the kill chain. The second one, it's the false positive alert. By the way, this is a big financial problem. Why? Because think about organization with 5 analysts in their SOC department. If each one of the analysts will spend 2 hours on a false alert, 5 double 2, it's 10 hours, meaning instead of getting 5 analysts full-time, you get 4 because 10 hours get lost on a false alarm. So pay for 5, get 4. How deception help here? Very simple. If you think about the concept, deception cannot generate false positive alert. Now, it may sound like another Fortinet guy with a nice marketing pitch, but wait a second before you hit me. If you're not aware of a fake door, you cannot open the door. This is the logic behind deception. If you're not aware there is a fake asset on your network, like your users, contractors, customers, they are not assuming that you have fake entities on your network, meaning they will never touch them. If you come to visit me in my house, you assume that I have one main door and another door to my backyard. But if there is a secret one that you are not aware, guess what? You will never open it. This is the same concept of deception. If somebody touch something fake, it's raised the flag. Why? Now, we have some system in the network that always polling the network monitoring to vulnerability assessment, raw sense of EDR. Right, we know how to whitelist them early in the deployment. So we know how to teach the system automatically and say, this is a monitoring tool. This is a faulty monitor. Ignore this behavior, not ignore the IP, because we don't want to be in the SolarWinds game where people compromise your monitoring tool that have access to the whole network. So we know how to whitelist the normal behavior. It's basically several of them. And from this moment, everything that touched the decoy, from ping, TCP connection, full TCP connection, access to the application, malicious, not malicious, for the decoy, doesn't matter. You touch the decoy, it's a game over. So false positive not exist with deception. So think about your SOC analyst back in my example. When they get a deception alert, they know that it's a high fidelity alert. And if you look on the timeline of the alert, and we'll see it in the demo, you get the whole story of the attack. It's not just an alert that you need to go to Google and find what is meaning. You get the whole capturing activity because it's like security camera. I will give you the whole story behind the attack because I record everything from the beginning. So if you look on deception working with the SOC, it is a very strong use case in business for us. We make the SOC more efficiency. You get few alerts from deception with high fidelity alert. So there is no way to miss the real alert because you are flooded with tons of false alert. And the third one, and I guess, to be honest, this is the biggest business in deception in general and also for Fortinet, it's the IoT OT networks. Why? Because this network, it's very sensitive. This network cannot have too many changes. The people that manage this network, most of the time, are not a cyber expert because they need to do OT stuff, IT stuff, and security stuff. So if you look on IoT and OT network, basically, we call it networks that cannot provide their own telemetry. You cannot put agent or the traditional IT security. Why OT customer choosing deception? Even Gartner was surprised early at the beginning when we start building the space. It was 3 main points. First, it's a passive solution. It's not basically impact the network. We basically connect, taking IP address that nobody uses, and that's it. So it's a passive, zero impact on the network. Second, easy to install that not require any network topology. Plug the appliance, put the network VLANs on a trunk or direct connectivity, and we will find the IPs that nobody uses, and we do it automatically. And the third one, go back to the false alarm. The guys on the OT facility don't have the time and the skills to deal with 100, 200 alerts per day. They need a single that is the problem. They need to stop their day-to-day work, look on the console, understand there is a problem, and handle it. There is no need to maintain the console every day. You don't need to analyze tons of alerts because you get few but very accurate. Now let's see FortiDeceptor, a quick run through how we deploy the platform. So once we plug the platform into the network via virtual appliance or hardware appliance, the system knows how to create the asset inventory discovery. We know how to do it active, meaning scanning, quicks and light scan. Passively, we can do it using a span pod. We develop a unique engine in the industry that can look on the traffic and extract your asset, their OS, services, and application. The system built your inventory. There is an algorithm. It's not machine learning and AI. I don't want to bring the buzzword to this discussion. It's a best practice algorithm that we developed using our 11 years experience in deception that basically look on the asset inventory and build your deployment recommendation. You get a logical map that basically draw your network and place the decoy with the right configuration. You have the option to accept it. You have the option to customize it. You have the option to discard and decide that you go to the manual route, that you look on the asset inventory and deploy the decoy manually. So now once we have the inventory and the decoy, either automatic or manually, the whole decoy running inside the appliance, consuming IP addresses that nobody uses. The system will generate the fake deception token. It's basically a script. It's an exe file. You can put it on your Active Directory logon script. You can use your SCCM, any kind of tool that know how to run an exe file. The exe file run on the endpoint and server between 5 to 7 seconds, insert the fake token into the operating system and disappear. Nothing left on the endpoint, zero tracing to understand there is deception here. The moment the attacker engages with a decoy, either directly or through a deception token, the system will raise an alert. The system will start recording the activity. During the recording, we analyze the data. We're using 7 different engines to analyze the data in real time, and we generate a timeline of alert with the whole details that you need. The IP address the attacker came from, the username, the tools that he used. We analyze the tools using Sandbox, AV, AI, Virus Total, IPS engine, Web Filter engine, Pickup engine. There is many of them that analyze the data automatically. End of the day, our goal is to have an analyst tier 1 looking on the console and understand the whole context of the attack between 10 to 15 seconds. I will tell you that back in the history when I started deception, the average time for analysts to understand the alert was around 2 minutes. Today, with the technology, the automation, and the new innovation from FortiGuard, we reduce it to 10 to 15 seconds. I'm sitting on one of the largest threat intelligence database in the world, and I can consume all the information I need in order to analyze better my data that captured from the attacker. Now, once I generate the threat intelligence from the attack stream, I will share it with your SIEM solution, with your SOAR solution, any kind of threat hunting platform that you have, and I will also convert it into mitigation command. I will use your firewall, EDR, network access control, and I also have my own mitigation connector that I know how to connect to the endpoint, and I will quarantine/isolate the endpoint from the network. And I do it automatically. No user intervention. It's a playbook, and it's very customized playbook. You can decide to isolate the attacker the moment he touched the decoy. You can decide I will isolate the attacker 10 minutes after the first engagement. You can give him a time to play. Or you can decide that when the forensics engine will categorize the engagement in a high-risk profile or even critical, let's quarantine the attacker out of the network automatically. So if you look on the FortiDeceptor platform, 3 main modules. Deceive and detect. This is the deception that we deceive the attacker to detect it. Forensics that give us the whole threat intelligence from the activities, and the mitigation module that quarantine and isolate the attacker. So we are not just detect and give you the story, we help you to mitigate the threat out of your network.
How much effort is gone into blocking the attacker, and what is stopping them from altering their identity and trying again? Like, how far back are you blocking them?
Yeah, so attacker always land on a real asset. Attacker never land from the internet on the decoy. This is the baseline for the attacker vector. So once the attacker compromise an endpoint, basically it do it through the internet. So there is a command and control that allow you to compromise it and move laterally. So I'm doing two things. One, I isolated the endpoint from the network, meaning quarantine zone. Second, I blocked the user he used in the Active Directory level. So even if he come back, he need to start again because I blocked both of them. And no, the other question you can ask is like, okay, let's assume that he touched the decoy, you detect it, and he will understand it as a decoy, so he may fingerprint your system. The answer is no, because he may find that this IP is a decoy, but there is thousands of them in the network, each one of them using a different configuration. So if he touches Windows and he thinks it's a decoy, there is a Linux, there is a Cisco, there is an HP, there is printers, there is a camera, you name it. He will never find where else there is decoy on the net. So one of the great value against sophisticated attacker, not the script kid, the ability not to fingerprint the platform. Think about it. If I'm an attacker and I learn how to attack in the military, like all the Israeli guys that serve the military, you can sit in the network for a long time without raising alert because you can run it very slow, very low threshold, and big part of the security today running on an anomaly, any kind of threat behavior. So you can scan, like probe a device like a single packet a minute or single packet an hour. Nobody will detect you. With the deception, it's working amazing because the moment you touch the decoy is a game over. And I don't care if it's a ping or a TCP connection, and I don't care if it's malicious or not. You touch the decoy, make the mistake, game over. So you cannot fingerprint the technology. It is a great value against sophisticated attacker, not a script kit that run reconnaissance so the decoy obvious will find it. Why people using deception? So first is non-intrusive. Again, everything running in the software, we consuming IP address that nobody use anyway, and we are not affect the network because the deception token is an agentless technology. So it's not even an agent. And one of the things about non-intrusive, and I will give you an example that I guess most of the people here will be amazed how much it's simple to detect ransomware. When I'm telling people that deception can find ransomware without an agent, all the CISO just, stop and say, wait a second, how you do it? And I said, keep your question for the deception token, because one of the deception token that we have, it's a network drive share, like any kind of network drive share that you guys have on your desktop. So think about desktop that have two network drives, the real one, and there is a fake one that instead of mapping into your file server, map it to a decoy that acts as a file server. And here is the trick. We hide the network drive from the user. Why? Because if the user click on my computer and he will see a new drive, he will click. We will get tons of false alarm. We hide it from the user. In order to see it, you need to have a command line escalation as an attacker, not as a regular user. So think about attacker that compromise your machine in the command line, in the background, just accessing the network drive to find information. The moment he touched the fake drive, he will get a lot of nice files, but he will raise an alert because somebody touched a fake drive that he shouldn't touch. Now, what we found during the years, that this token can detect ransomware. Because what ransomware doing? Ransomware can be sophisticated. It can be using nation-state exploit. It can be super smart, compromise your perimeter. End of the day, ransomware need to encrypt file. The moment he encrypt the fake files that on the fake drive, we detect the encryption because the decoy holding the file, the decoy monitor the activity on the file, we detect the encryption. The moment we detect the encryption, there is no policy, let's give him 10 minutes or let's see if it's malicious. If the system get decision that is a ransomware, immediately we isolated the endpoint from the network. So you may lose 2, 3 real files, but we take it down So you save the whole storage or your file server. And again, detecting ransomware, one of the biggest challenge today in the cyberspace, using network drive share that is not even an agent. As I mentioned, so simple, so powerful. This is the non-intrusive of the platform. Second, we provide early detection. Why? As I mentioned, attacker going across the network, the attacker looking ahead, every point, every angle, every corner, there is deception around. We know how to take down even insiders. So if you have a user that gets a desktop and he decides to penetrate their own network, he will try to collect information from his desktop. He will extract data and will be happy to find admin user. He's not aware that it's the fake. The moment he will do the move, we will detect it. We reduce the dwell time. Again, early breach detection, low overhead and maintenance. It's deploy and forget. You deploy the platform, forget. There is no need to open the console every day. There is no maintenance, fine-tuning of configuration. There is nothing to do. You deploy and forget, and soon, early next year, we will have the dynamic deception operation module, meaning the decoy will replace the location, the decoy will change configuration profile dynamically without user intervention, and it's offered great value for the money. It's not expensive solution. Yes, sir.
I think you asked, or you brought up a really awesome example of the fake network share and can detect ransomware because the fake files are being encrypted or changed in some way. I think that's super cool. I really like that. But I have to know, you keep mentioning non-intrusive, passive, things like that. In order to do that kind of detection, right, we have to control or we have to make a configuration change on every endpoint in the environment, the real endpoints. I have to make some sort of network share.
No, but you know, you have two network share, you add another one. Network share is not an agent, it's configuration that you can add. We hide it from the user. So it's zero impact on the endpoint. It's zero change because the user don't see it. It's basically when you open the
I understand that the user doesn't see it, but the system administrators need to push out that change to the devices, right?
Yeah, but the change is basically encapsulated into one binary file, what we call script token. He run on the endpoint on the login for 5 to 7 seconds and disappear. He will not run again. It's running one time. If you not reboot your machine or restart it, they will not run again. Because when you reboot, you lose part of the token because we inject it into the memory. But if you not reboot or shut down, the token will run one time. This is the reason why you need a repeatable process from the Active Directory or SCCM. But if you look on the footprint, I add fake credentials to your Windows Vault. It's configuration. I copy files to a temp folder or recent folder. Files, nothing changed. So yes, I'm doing something on the endpoint, but it's not modification like agent. It's not require permission. By the way, I'm doing on the user permission. I'm not doing even with admin permission. I take the user permission and insert the data. So for me, it's a non-intrusive because I am not modifying nothing on the OS level. Nothing, no DLL, no files, no kernel, nothing, not file.
Okay, I guess it's just a matter of just mincing words or changing the words a little bit because if I have to involve a whole nother team within the organization to deploy the detection, then it's not intrusive, right? Now I have to get permission to push out this little agent, this small binary that you're talking about, get that approved, get that executed, make sure the domain or SCCM team can do that. It's different than just spinning up a VM and pushing a spam port to it. That is really passive. Now we're starting to get into, well, I guess it's still passive detection, but it requires active administration.
Yeah, I get the comment. It's, you know, it's interpretation of the word non-intrusive. But yes, you know, the token, you have a handshake with the endpoint. I get your comment. It makes sense on the interpretation of the non-intrusive word.
And then the whole deception appliance or VM or whatever it's, however you're hosting it, however you're providing it on the network, does that integrate into, I guess, Fortinet's SOAR platform? Like how do we take the detection events and sort of automate things like taking the real file share off of a host or something so that ransomware doesn't spread so far, or isolating a particular host in a VLAN or a network or something. How do we integrate that so it's not just detecting on an island?
Yep. So basically, rule number one in Fortinet, you cannot release your product first GA version without be part of the fabric. So we have our fabric language. Fabric is not like a marketing buzzword. It's basically a protocol that all the product of Fortinet share, exchange information, and leverage each other to exchange information. And when FortiDeceptor, it's part of the fabric, and we support all the Fortinet products. So if we take the SOAR, for example, I push the alerts into the FortiSOAR, and the FortiSOAR already have content pack, meaning the playbooks out of the box that you can basically create in order to get the data and orchestrate a response. If I actually connect to the FortiNAC, I know how to let the FortiNAC decide to isolate it, meaning move to a layer 2 VLAN or block the switch port. If it's a firewall, I know how not just blocking a rule, I also know how to publish the alerts into the fabric so the firewall can take an action. You can see, by the way, the installation, the deployment of the decoy in the FortiGate widget dashboard. So you can basically see the whole deployment, and soon you can even manage it from the UI of the FortiGate into the FortiDeceptor. So each product that we have on Fortinet, I know either to enrich with threat intelligence or to ask him to help me to isolate it or quarantine. This is a full fabric conversation, and the beauty of it, if I want to add something, it's not needed like another dev cycle. I taking the protocol, I leverage the method, and I basically time to market. It's for me as a product guy easy. Less than a month, I can release the code, and I am part of the fabric and add more and more capabilities because there is a fabric team that always expand the schema of the protocol so you can do more and more things. Fortinet is a big vendor, so other third-party tools also part of the fabric. So we have even common language with other players in the market. So if I want to have conversation with other vendors, firewall vendors, EDR vendors, NAC vendor, either do it over the fabric or through the REST API. I have two ways to choose. So I'm a full fabric player, and it's done automatically. I will show you in the demo. It's a 2 clicks UI. It's not like script or you need like an expert to do it for you.
Got it.
Moshe, I want to jump in and ask a question with regards to the script that actually has to be run. It's an administrator who's managing it, and being an old Windows admin and running a lot of domains, I know how frequently like scripts do fail or not run. What is the probability of those, always running or any issues? And now you have the admins managing the overhead of making sure that these run constantly during like a login or something. Is there reporting capabilities? Have you seen these fail often or?
Yes. Basically, it's a good question because the token is basically what we call an active token, meaning each time the token run, he communicates with the closed interface of the FortiDeceptor because we have a lot of interfaces connected to the VLAN. So he go to the one that exists on his VLAN. He authenticated to the FortiDeceptor and asked if there is a new package because you can change the deception token. You can create campaign. When you create a package, we call it campaign. You can create many campaigns because, campaign for IT is not campaign for executive. So each time he authenticated using a token over SSL and download the configuration. And once he finished to run, he pushed back the reporting. So in the FortiDeceptor, you will see reporting that show you all your inventory, and each one of them, each one of the token, if it's run successful or fail, and you get a full visibility and report what have been done or what we miss, or if something get blocked or something. So you have the full visibility without relying on your IT people. You can get it from the console because we report back. So on the kill chain, as I mentioned, we have several places where we can detect the attacker. Beacon, of course, all the ransomware that spread, people that get scared, but I always laugh because if you have deception, these spreadable malware are the easy to take because they scan the whole VLAN. The moment they touch the decoy, they can be out. Weaponized, we basically let the attacker run exploit, binaries, tools, and etc. We know how to collect everything. We know how to give him the feeling that everything is okay. He can run it, and we basically capture it automatically in the background and analyze it. Like, again, also the exploit section. Installation, again, if you decide as an organization to let the attacker play with the decoy more time, you will capture also the installation of the tools, the command and control of the tools, and also the action, meaning we are not just letting you know that there is a problem, we also know how to mitigate the problem, and it's very important. It's basically one of the things that help deception to get more market share when we add the mitigation, because in the beginning it was just a detection tool, and security people always like to get two things: many alerts on the dashboard to get more budget, and mitigation that somebody will do the job for them. So once we add the mitigation, we get just more footprint in the market, because people like the fact that you're not just telling the problem, you solve the problem. So the question that was before, it's basically, you asked it before, but this is the way that we look on the ecosystem perspective. So from one hand, we orchestrate response, EDR, other EDR solution, SOAR, other SOAR solution, FortiNAC, other NAC, FortiGate, rest of the firewall. Each one of the category, we have not just FortiNAC, we have all the most common brand in the market, the big one. And the threat intelligence, we will send it to your sandbox if you willing to have second opinion, because the decoy acts as a sandbox when the attacker play on the decoy. But if you want to get second opinion, we can send the malicious code to a sandbox and get back the report. And guess what? You don't need to call the sandbox guy. We retrieve the report and it's embedded in the UI. We support all the SIEM solution. We have integration, interesting integration with the solution. Hopefully we have time with the demo to show it, and also the FortiAnalyzer. So this is case study in short. Huge gas station company have 330 gas stations. For them is 330 points for getting attacker. So they use deception to protect the gas station facilities because there is IT and OT there. So using deception. Second one is a bank that willing to protect the core banking system. It's like big AIX, S400, all the big animals that you cannot put EDR, AV, you need to put something around. So they use deception because they bought the system from external companies. So they buy a core banking plus 150 people that connect, maintain the system. So they use also deception. 4 main use case in our business: IoT, OT, big deception. Almost 40% of the business. Ransomware mitigation, I mentioned. Lateral movement, the classical one, early breach detection, and threat hunting, make your SOC more efficiency. We speak about why Deceptor, if you want to know if somebody inside the network, protect devices that cannot provide their own telemetry, and we fix the false positive alarm. Yep, so this is the console. Let me maximize it. Yep, so if you guys familiar with the guys and ladies, familiar with Fortinet UI, so we keep the Fortinet UI across many of our products. The idea is to have much more fast training for people. So we see the dashboard, we see summary of the incident, the system platform, all the license engine, everything that is up and running. We see the services distribution. This is all the fake services that we deploy on the network. We can see the decoy OS, some system resources, just to give you a heads up if the system it's overloaded or not. Most of the time, you will see this number because the decoy running in an idle time, meaning nobody touched them, so there is no resource to consume. Many other widgets, and also dynamically, you can add more widgets as you want. Classical Fortinet dashboard, and let's go for the deception menu. So first we have the deception OS. This is the deception decoys. So you get many templates from Fortinet out of the box. On each version, you get several of them. Linux, like CentOS, ERP system. Let's customize. We will speak in a minute. Even FortiGate as a firewall, you can get it as a decoy. IoTs, medical, Linux, point of sale, SAP. We have the all SAP component as a decoy. All the OT, IoT, SCADA, we have many of them from the all leading vendor, Rockwell, Siemens, GE, Schneider Electric, Phoenix Contact, and etc. more Linux, Ubuntu's, voice over IP, Windows desktop, and more. So this is the template that you get from us. It's customized template. You can customize everything on the services from credentials, access, banners. You can bring your own files. So we can host on the decoy files that belong to you, and etc. And let's assume that you come and say, Fortinet, I like you, but I need something more basically identical to my environment. Custom decoy, upload an ISO file or Linux distribution package. The system will allow you to install everything internally. You can upload your gold image, run the installation, put your software, even put your EDR, AV, connect it to your domain. Everything identical to your network. Once you finish, you will have the save command. And once you click on the save, you get a decoy that is basically your own decoy. How you recognize it, all the decoys that are customized get the name cas underscore, the name that you gave it during the deployment and the installation. So you can see here that I have 3 of them that I generate Windows 10 and Windows Server. On the deployment network, this is where I feed the appliance with the network that I'm willing to deploy decoys. Again, 2 options here. Manually, I can add them from the UI, or automatically, I will plug the span port and you will see all the network that I learned from the sniffing mode, and I will have all the deployment network here. Low resources is where you bring your own style. You basically can upload files, credentials files, everything that you're willing to influence and to customize the platform based on your needs to be identical and mimic your environment. Each one of the component that you upload, you give it a name, tag, very simple. Why? Because when you deploy a decoy and you attach the tags, the system take your information and customize the decoys using your instruction. This is very important. On the deployment wizard, let's count together 3 times. This is the first click of the decoy. Let's give it test 1000. Let's choose, let's take a Linux one, Linux Ubuntu. I get all the services that I expose, SSH, Samba, TCP listener, if you want to have a custom port that is something that you have specific in your network, HTTP, HTTPS, you can upload your own certification. Git, GitHub, you can actually protect your dev segments with Git. ICMP, if somebody pinged the decoy, give me an alert. FTP, you can change the banner, the port, you can allow anonymous, not anonymous, you can apply user, not user. So all this configuration, you can do it manually. You can choose one of the one that you customize. You click generate lures, and I get everything automatically configured in the platform. So now let's take the FTP down for a second. I can launch it immediately. I can choose reset decoy. Reset decoy is basically, it's the time. I can give the attacker 10 minutes. After the 10 minutes, I will quarantine and I will revert the machine back to the original state. I click next. I choose the network I want. If I choose, let's choose VLAN 67, I can choose static or DHCP, and the system, both method will find the IP automatically. Let's take for the example DHCP. I can change the MAC address. If the decoy was a decoy vendor like Cisco decoy or HP decoy, the system will give you automatically the MAC address. So we even customize the MAC address to not let the attacker think that something is wrong. Because if he will scan the Cisco decoy that will not change the MAC address will be the KVM virtualization layer that we are using. So I'm choosing one IP, I can choose more, click down. This is the deploy button, 3 clicks, decoy up and running. This is all the decoys that I deploy. You can see the list. If I want to see the configuration, click on the eyes. I can see the configuration of the decoy. I can see the IP address and the configuration. I can see, I can stop, delete, I can create a template. Next time that I want to deploy something similar, no need to do it again. Just click template. You will get it as a template and you can replicate it. You can see decoy from Cisco decoy, ES6 decoy, Linux decoy. We have interesting capabilities, what we call the outbreak alert. If you're familiar with FortiGuard Outbreak, it's where we publish all the big vulnerabilities that go into the news. We always publish how to deal with it using Fortinet product. So in FortiDeceptor, we reverse the vulnerabilities. We take the vulnerabilities and add it to the decoy, so you can run a single vulnerabilities if you want to find if you are vulnerable. You can deploy like log4j decoy with a single vulnerability and try to see if somebody in your network looking for log4j. So it's the ability to emulate specific vulnerability, and mainly we take the big news that everybody gets concerned. So you have a decoy, IoT, OT decoys, printers, Rockwell, SAP, there is long list. Let's take the Rockwell PLC. If you guys came from the OT space and saw Rockwell PLC, so an attacker can access the Rockwell PLC. This is what he will see. This is the web UI of the Rockwell. I can click all the UI here. Guess what? Everything you see here, totally fake. It's not exist. It's illusion. The attacker, happy, he click, he look on the parameter, he look on the configuration. We even match between the IP of the decoy to the UI. The attacker feels safe that he compromised an OT device, and guess what? He not compromised OT device because basically we emulate it and do it as a fake.
You guys just emulate the software layer of the equipment on the decoys, or you also emulate the hardware so you can detect an attacker going after a hardware vulnerability as well as a software vulnerability?
Yeah, it's a good question. We have three versions of decoys. We have the decoy that's running the full operating system, Linux, Windows, so it's a full-blown OS. So it's everything like real. Decoy from the IoT OT, it's what we call using emulation code. It's look and feel like the real without running the actual OS. So we emulate the OS on the fingerprint level, the services, the stack, the protocol, the web UI, we clone it. If there is a CLI, we teach the emulation, the command, and the response. We basically take a real device, running all the command, capture them into a TXT files, and each time you run the command, you get the response. And the next gen of the platform, mid next year, we find a way. Still, it's in investigation of patents, so I cannot expose much, but think about going to Linksys website, download the firmware that you download for your router at home, upload the firmware into my platform, and I will run the Linksys router as a real operating system, not emulation. So it will be identical on the software and hardware level, same to same.
I know in one of the other slides you kind of mentioned, traffic emulation. So for like the OT network, are you generating like Modbus traffic to be able to, lure people in from a traffic perspective?
Yeah, so part of the traffic that we doing, it's, for example, if it's in OT and stuff, so if you have a Cisco device, we can send the CDP packet to the wire to give him information on the routing. It can be all the protocol, NBNS protocol for responder. We will see in the demo, I have alerts specifically to your questions. We can send UPnPs, all the packet that he expect to see on a switch level. Because remember, if I'm running inside the network compromised machine that connect to a switch, I will see broadcast multicast unless I'm doing man-in-the-middle attack. Otherwise, I will not see unicast traffic. I will see broadcast multicast. So I cannot send traffic, TCP traffic. He will understand that something is wrong. He cannot see traffic he shouldn't see. So I must play the game of his expectation. So I will put traffic into the wire that he expect to get. But if he will do man-in-the-middle to see other traffic, I will detect the man-in-the-middle because I have IPS engine in the firmware that know how to find this information. Also, there is attacks like responders, attacker looking, a malware that looking to find endpoint that looking to find a asset that not exist in the network. There is a famous attack called responder. If there is an endpoint that try to find hostname that not exist, the responder will answer yes. I am the asset for you. The Windows will try to authenticate it. He will capture the credentials and run reverse attack against the compromised asset. So this is also things that we send to the wire. Again, if I will send unicast packet, it will look fishy. I'm sending the one that he's looking to get. We are going to have features And again, it will be feature optional. It will not be automatically. The customer can upload the pickup file and let the decoy send the files to the traffic to the wire based on your pickup. Again, it needs to be a reasonable pickup and not something that will look fishy from attacker perspective. This is an SAP decoy. You can access the SAP and you can see the application. We clone a real SAP platform. So we have an SAP team expert in Fortinet that have a huge lab of SAP. So we basically take an SAP platform and we clone everything. So you think like it's a real SAP, but it's totally fake. And another OT device, for example, this is Moxa, one of the most famous device in OT, convert serial to TCP IP. Again, the same concept. You can see it. And even if I attack it from a Kali box that we see some attacks later, he will respond exactly as you expected. So if you run nmaps or if you run exploit or run on the protocol query, he will get answer he expected to get. This is the level of the maturity and how we emulate platform in the network. This is the deception tokens. This is basically the package. I can create a campaign and guess what? There is no token. Why? Because all my decoy are DHCP. The system has protection to protect you. If all the decoy DHCP, you cannot generate token. Why? Token from the DHCP decoy, it's in risk. If the decoy will change IP, the token will not detect the attacker because the token will send the attacker to IP that not exist. If there is a static IP, we will get list of the token. And if you deploy the token, this is example for the status that you ask me. So you can see this is the IP that I deployed the token, and I can see the tokens that deploy and if it's successful or not. In this case, we deploy HoneyDocs, SMB, the network share, and RDP credentials to a terminal server. HoneyDoc, interesting token. It's basically we're taking Office files and PDF and we put some pixel technology inside, meaning you open a Word file, it looks interesting file. In the background, without your notice, the Word file communicate with the decoy over an HTTP connection. Why? Because in the file, there is a pixel that the file need to download from a decoy. So the moment the file communicate to download the pixel that your eyes cannot see, you raise an alert. So just opening file, we will detect the attacker. It's not required to enable macro. It's not required to click on something. Open the file, boom, you are out of the network. We detect you. Deployment map, it's basically how we deploy it automatically. So we can see that we have the map here. This is an active deployment. I can click discover and deploy, feed the network with the network that I want to deploy. This is the list of the port. I can add more port if it's something specific to my network. I can decide how many decoy I want or let the system do it automatically. Once I click discover on the platform, the system run the discovery. And on the map, we will get recommendation. We will see yellow entities that basically this is the decoy the system recommend you to deploy. You can click on each one of them, customize it, approve it, discard, and click approve. The whole decoy will run automatically. Asset discovery is where we see all the assets from the passive and the active. You can see the settings. We're not just supporting IT protocol. We are the only vendor in the market that we support OT protocols. We know how to make asset inventory of OT platform. We support this protocol. And the next version in 2 weeks, we will add 9 more. So in total, FortiDeceptor will support 26 OT protocols. Very unique capability for us. Safe list is where basically we whitelisting things that we don't want to get alert. Quick to the incident. And let's see how we see the timeline of the incident. Let's take an alert that attacker copy a malicious code. So we can see here the attacker user, we can see the IP he came from. If he attacking ICS network, so we have also the MITRE mapping. We can see that all the pickup stream of the attack, we can see that he basically copy files. So you can download the file as an evidence. We scan with an AV, with an AI, we send the MD5 to VirusTotal, we send it to FortiSandbox. If you have other sandbox, we integrate it. You get all the reporting embedded. So you can click here and you will see the files of that getting from VirusTotal with all the engine. If I click on the report from FortiSandbox, you will get the PDF here So basically, you can get everything embedded in the platform of the timeline, and you can see the timeline here, what kind of command, what kind of user, and also you can see it as a table. Again, if you better for you. So this is the powerful of the timeline alert, how you can understand the problem quickly. Attacking map, it's basically you can see the whole attacking visualized mode. This is the attacker. This is all the alert. If I will click on one of them, it will take me back to the incident response, incident alert. MITRE ICS, if it's an ICS environment, we map all the alerts on the MITRE framework. If I will click here, it will bring me back the alert that related to this MITRE framework. Fabric, this is the integration with FortiSandbox, Cuckoo Sandbox, VirusTotal, quarantine integration. Let's see it in action. We speak about the Fabric. We are proud in our Fabric in Fortinet. Let's see how we do it in real time. So I will enable the Fabric integration with FortiGate, and I will open two consoles here. Look how much it's simple. I make the integration. You can see on the edit, the firewall IP, port, username, password, VDOM root, expiry. I choose that the moment he touched the decoy, meaning any kind of severity, just block the attacker. Two screen here from attacker machine. I will run a ping here. So I have connectivity. I am the attacker. Now I will basically attack the network. I attack one of the decoy. You ask me about the OT. This is how I attack Modbus, and I get all the Modbus parameters from the device. Look, the ping stop. Why? Because I'm quarantined. You see, there is no ping anymore because there is a blocking rule that do it. If I go to the quarantine status, I can see that I'm in a quarantine from 60 minutes. Now, if the analyst get the quarantine Friday night, you need to bring back the asset from some reason. Nobody answer on the call because it's Friday night. No worry. He click, unblock, and he bring back the asset. Each quarantine method have unquarantine. We are not leaving the analyst to find people to help him. So we will see the unquarantine soon, and the ping will come back soon.